Hello, Honors Algebra students. Mr. Lawrence here, and this video will briefly talk about the golden ratio, the video you watched yesterday from YouTube, but then I'll go over giving simplified forms of radical numbers and actually using the golden ratio to help us solve a problem. So anyway, briefly, the golden ratio is kind of a mystery. Okay, saw in the video how it applies to your body and to flowers. It's actually comes about as a solution to this quadratic equation. If I identify A, B, and C as 1, -1, and -1, right? That looks terrible. Sorry, I had a little lag going on there. My equal signs all got messed up. Okay, so that looks a little better. And then I use the quadratic formula. X equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. When you simplify that, you end up getting 1 plus the square root of 5 divided by 2. And that is the exact form of the golden ratio. I know the art teacher, if she is a teacher, I'm not sure, I think she is, in the video yesterday kept talking about, 1.6 or 1 6/10. And that's a rounded version of the golden ratio. It shows up sometimes, but as you get more and more complex, that irrational number gets longer and longer and longer. It actually, not that it gets longer, but when you divide it out, you get longer and longer decimals, okay? So when you have the biggest rectangle here, let me see, I'll outline the largest rectangle. Okay, that's the one. Oh, that's not going to work. How's that? There we go, this one here. Okay, this is said to be in the golden ratio. Okay, because the distance from here to here is 1, and then this is 1 6/10 times the distance. All right, and when you divide, you get a number with the golden ratio. And then the crazy thing is, this leftover rectangle, if you cut it there, this rectangle here, okay, this part, you can make a square out of this, and the leftover rectangle here is in the golden ratio as well. And then if you take this leftover part and do the same, make a square, sure enough. And it just keeps happening. You probably can't do it infinitely by drawing because the things get smaller and smaller. But theoretically, you could do it infinitely. Okay. Now, she was mentioning the Fibonacci sequence. I don't know if you're familiar with that. That's where you take the numbers 1, 2, 3, 5, 8. Can you tell what the next one's going to be? Well, it's going to be 13 because 5 plus 8 is 13. So therefore, the next one is 21. Okay? And these numbers create the Fibonacci sequence as well. Okay. Anyway, enough about that. I just wanted to mention it briefly. And it's important to know most people use the decimal. However, this part is going to be useful for a problem we're going to do later on in this video. Okay, so let me change direction here. They want to know the simplified form of this radical number. Now, this is considered a major no-no in mathematics because your denominator is irrational. The denominator cannot be irrational. It's not allowed, okay? It's not simplified. So if you gave me, 5 over the square root of 2, I would not accept that as a simplified answer. I would multiply it by the square root of 2 over the square root of 2 because this is really 1 in disguise, right? And so I would get 5 rad 2 over 2, and there we go. That's a simplified form. So how do we handle something like this one? Well, let's see. We have 10 over the square root of 7 minus the square root of 2. All right. Now, I do want to multiply by a form of 1, but what form do I use? Well, I'm going to apply my knowledge of factoring, the difference of perfect squares. Okay, because I know that when I square a rad, it gets rid of the rad, right? They're inverse operations of each other's, rads and powers, as long as you're doing the same rad, square root and squaring, okay, or cubed root and cubing. So I'm going to use the idea that if I do x plus 2, or better yet, how about x plus y, times x minus y, that I'm going to get a squared number here. I'm going to get a squared number over here, and then my middle terms are going to cancel out, leaving me with just a squared number minus a squared number. Okay, so when I do that on this, what am I going to multiply by? And it's such a simple thing to do. I'm going to multiply the denominator, put in parentheses here, and I'm going to multiply by the square root of 7 plus the square root of 2, or rad 7 plus rad 2, because that will allow me to multiply the rad 7s, getting rid of the rad, multiplying the rad 2s, getting rid of the rad, and then when I do the other parts of the double distribution, I'm going to get a positive rad 14 and a negative rad 14, which will cancel out, and therefore my denominator will be rational. Okay, now if I don't do the same exact thing to the numerator, then I'm changing the problem. See, I'm just multiplying by a very special form of 1. Okay, so when I multiply here, I'm going to get 10 times the quantity of the square root of 7 plus square root of 2, or rad 7 plus rad 2. And in the denominator, I'm going to get 7 minus 2, which better yet is 5. Okay, now this 5 can cancel into that 10 2 times, and so now I have 2 times the quantity of rad 7 plus rad 2. And if I distribute that, I get 2 rad 7 plus 2 rad 2. Can't combine them because they're not like terms, but now I have a rational denominator. It's 1, right? 1 is a rational number. Okay, let's see how we do that with this one. Same exact idea. I've got negative 3 over rad 10 plus rad 5. Of course, it's always easier to simplify your rads first if you can, but these can't be simplified. So I'm going to multiply by a special form of 1. I want to get rid of the rad 10, so I need a rad 10. I want to get rid of the rad 5, so I need a rad 5, but I want those other two terms to cancel out, so since this is a positive, I'm going to make that a negative. Put them in parentheses so I know I'm double distributing, and I have to put the same thing in the numerator. All right, so when I do this, I'm going to get negative 3 times the quantity of rad 10 minus rad 5. That's going to be over 10 minus 5, which of course is 5. So this won't simplify like the last one did, so I'm going to leave it as, or I'm going to distribute the negative 3 in the numerator and get negative 3 rad 10 plus 3 rad 5, because the negatives canceled out, over 5. And I'm going to go with that as my simplified answer. Notice my denominator is rational. So you never, ever, ever want to have an irrational denominator as a final answer. Okay? All right. Okay, so this problem here says fiddlehead ferns naturally grow in spirals that fit into the golden rectangles, or golden ratio. What is the width W of the fern shown? So I'm going to use a proportion, okay? Now I could say, well, W over, no, I better not do it that way. I better go the other way, sorry. There we go. So I think it's going to, well, wait a second. Hold on, let me pause the video. I want to check something really quick. Okay, sorry about that. I just wanted to check something. So I'm going to set up a proportion. I'm going to start with W over 4. I misspoke there. It's 4 over W, and that's got to equal the golden ratio. And I'm going to use the golden ratio as 1 plus the square root of 5 over 2. Okay? Now, I'm going to multiply to get rid of my denominators. So I got to multiply this side by 2, but that means I have to multiply that side by 2. And I have to multiply the left-hand side by W. But then I have to do that on the right-hand side. All right. When I do that, the W here is going to cancel, and I'm going to have an 8. And over here, the 2 is going to cancel, and I have to distribute the W. I'm going to get W plus W times the square root of 5. Okay. This is looking a little bit strange. I think that perhaps in this situation, I'm going to go ahead and not distribute. I shouldn't have distributed. I'm making the problem more complicated than it needs to be. So let me rewrite this right-hand side as W, or the quantity of 1 plus rad 5 times W. Okay? Now I'll get W alone by dividing by 1 plus the rad of 5. Of course, I have to do that over here. 1 plus the rad of 5. All right, and I'm just going to change sides. So I'll have W equals 8 over 1 plus the rad of 5. But this is an irrational number. So I'm going to multiply by the conjugate. That's what this is called. I don't think I've mentioned that yet. It's the conjugate. I'll do it to both the numerator and denominator so that I'm only multiplying by a special form of 1, therefore not changing anything. So this will become W. Numerator of the right-hand side will become 8 times the quantity of 1 minus rad 5. And that'll be over 1 minus 5. You can do a little simplifying here. 1 minus 5 is obviously negative 4. And so then I'm going to get negative 2 times the quantity of 1 minus rad 5. And if I distribute, I will get negative 2 plus 2 rad 5. And there you go. There is your answer. Okay, so that's rationalizing a denominator by using the conjugate. That's what I needed to show you for today's video. And yeah, it had some background knowledge of the golden ratio because they mentioned it in the problem. All right, that's it for the video. Have a good night, everybody.